Hello everyone, so this video will be a discussion on how to locate or estimate the location of contours using interpolation, and then this will also be a guide to the laboratory exercise that we will be doing. So this is the actual given in the laboratory exercise. As you can see right here, we have a points distributed in a grid-like pattern. So we have here squares, and then the distance here from in the ground actual is 20 meters. Okay, and these numbers right here are the elevations of the points. Now, our goal is to create contours here with a contour interval of 2, starting from the contour with the elevation of 68 to 84. So that would be 68, 70, 72, 74 until you reach 84. So, how do we locate these contours and how do we draw them? So, the first thing that you need to do is you need to examine the points. Let's say we want to draw the contour with the 84 as the elevation. So, let's take a look. So, let's take a look at pairs of points. Let's see here. 83.316 right here. 83.316 and 84.079. So we can say from these elevations that 84 is somewhere between these 2 points, right? So that's cool. So let's just leave it with a check mark right there. And how about here? 83.316 and 83.076. No, right? So we don't have 84 right there. So here, no. And here we have 84, right? So 84 is between 83.995 and 84.079. We are sure of that. And also it is here, right? So it is also here. And then it is also right here. It is also here, right? So let's take an example. Let's say we want to compute for the location of 84 given these two values. We have 84.176 and 83.152. Okay. So we will use the concept of similar triangles here. So again, this is 84.176 if I'm not mistaken, and then 83. This is 83.153, was it? So 152. 83.152. Okay. So we use the concept of similar triangles. We have here AB. So this horizontal distance AB over BC, which is the difference between 84.176 and 83.152, is equal to AB, the distance here from point A to our target, which is C, with an elevation of 84. So over BC, which is 84 minus 83.152. So let's write that out. So we have here AB. And we also know that AB, the distance in AB in the ground is 20. So let's write that out. 20 all over BC, which is 84.176 minus 83.152. Okay? And then is equal to, this is equal to AB, which is, that is what we're looking for. Let's just write D as a variable for that. And then BC, which is 84, our target, minus 83.152. So if we calculate that, we will find out that D is 16.5625. Okay? So now we have our distance right here. So now we know that 16, so this is originally, so the ground here is 20, right? This is 20. And then we know that from this 83.152 point right here, we have, so if we go 16 meters in this direction, then we will have, this is the location of our contour line with an 84 elevation between these 2 points. So we know that. But if you already print this out, let's say you will submit this as a PDF, right, as an image. So the first thing that you need to do is you need to print this pattern out in a bond paper, right? So that's the first thing that you need to do. or if you want to do it in a PDF format. So it's up to you. So you have the freedom to do that as long as you draw the contours correctly. Okay, so let's say for example, if you take the first route that I mentioned, you print this out in a bond paper, for example, and you measure. So the first thing that you need to do is you measure the distance between the points. So you can set it up such that the distance between them is 3 centimeters, so that you can stretch the image out such that it stays in 3 centimeters or 2 centimeters. It depends on you and depends on the fit that you want in your bond paper or the size, the most convenient way for you to draw. So it's up to you. You have the freedom to set this distance right here. So let's say you use 3 centimeters, okay? And you know that the contour is in here 16 point something. So how do we locate it in the bond paper? So what we need to do is divide. So 16.5625. So 5625 divided by 20 is equal to x. So let's just write out x as variable over 3, right? So x here will be, if you calculate that out, you will get 2.484. So you get a ruler and then you measure. You get a ruler and then you measure the point here from this point right here to this point, and then you will get 2.484, and that is the location of your contour line with 84 elevation. Okay, so how do we draw the contour lines here? So let's say between these 2 points, 84 should be near here, right? Should be near here somewhere. I'm just estimating this just for the sake of demonstrating how to draw the lines. So 84 should be near here, somewhere here, and then in here it should be about near here. So how do we draw it? So when we draw it, we do not just let's erase the other features first. Okay, let's erase them first. Okay. So when we draw them, we do not just connect them like that, no? We don't do that because that is not how contours look. So it is important to remind ourselves that this is only estimation as well. Even though we're calculating it, this is still there's still a degree of estimation here because we don't have the exact data in between these points. Okay, so but we need to connect them in a smoothed out manner. Let's see. Let's say from here, you don't draw a straight line, but slightly smoothed out like this and like that. And then connect here, 84 here. So all of the points here are 84, right? So the first thing that you need to do is you need to plot out the points first. You need to plot out the points, let's say here, and you plot them out so that you will have an idea of how you're going to trace the points, okay? So that it looks conformant to how contours should be drawn. So let's say you find out that this is this 84 this 84 contour line closes upon itself, then you can connect it like this. And let's say if you want to plot out 82, so you do the same thing, you calculate the positions of 82 and then you connect. So once you notice the pattern, which is this is a hillside, then you know how contours behave on hillsides, right? So I just give you a hint na lang, this is a hillside. So you can expect that the points, the contours are radiating from this, starting from this 84 contour line, radiating outwards. Okay, so you know how hillside contour lines look. Okay, so that's how you draw the contour lines, and this is how you do the exercise. So the thing that you need to do is you need to draw all the other contours until you reach the contour 68 with intervals of 2 meters contour intervals. So in completing this exercise, you have to draw this by hand. So you take a picture of it and then you upload it in Moodle. So just like how we submit all our submissions. And yeah, so in calculating, you can use a computer as well in Excel if you want. So in order to speed up the calculation process, so you can do that as well. So That's it for this video. So I hope you learned how to interpolate and then use interpolation in estimating the location of contour lines. So thank you for watching, and I will see you in the next module.